During the first week of exploring multi-agent architecture, a glaring anomaly emerged in standard AI design. Models account for the agents themselves, but they overlook the space between them. They ignore the environment where emergent alignment actually occurs. Standard industry architecture treats intelligence as a linear pipeline. Data moves from point A to point B to point C. This structure prioritizes frictionless speed and immediate answers, discarding any process that delays the final output. Bearingfield replaces the mechanized track with a navigable force environment. On the track, the rails dictate the destination. An agent locked in a pipeline will execute catastrophic commands or hallucinate wild outputs simply because the system physics force it to keep moving forward. It cannot question its heading. It can only accelerate. Bearingfield operates like a ship in open water. The medium does not dictate the path. The ship must read the surrounding conditions and continuously orient itself within the environment to navigate safely. True autonomous alignment begins with the agent's relationship to a deliberately shaped environment. This environment operates on a foundational axiom. An agent must know its exact physical and logical position before it is permitted to process a task. In surveying and navigation, this is called taking a bearing, measuring the precise angle between a fixed reference point and your target. You do not move until the bearing is confirmed. This diagram illustrates registration before reasoning. It is mathematically modeled as a gate. When the agent is disoriented, the gate value is 0 and compute is blocked. Only when the agent proves its orientation does the gate shift to a value of 1, authorizing the work. Holding this orientation under computational load generates the field. When an agent resists the urge to immediately answer a prompt and instead holds its position, an invisible force structure ripples outward. This topographical valley acts as a shaped attractor. It draws multiple independent agents into alignment using the geometry of the system, without requiring a central orchestrator to issue explicit individual instructions. System alignment emerges as the inevitable result of holding a strict orientation under computational pressure. The technology industry optimizes for a single metric, eliminating friction. The goal is a seamless experience where all resistance is removed to achieve maximum operational speed. But zero-friction intelligence carries a high risk. When nothing resists an initial computational impulse, systems produce sycophantic, unaligned, or outright monstrous outputs. A system moving without resistance will execute a harmful command as efficiently as a helpful one. Bearingfield treats deliberate friction as load-bearing infrastructure designed to maintain the system's course. This graph tracks system resistance. The steep peak is static friction, the high startup cost of the orientation gate, demanding energy to verify identity before motion. Once moving, the curve settles into dynamic friction, ongoing governance resistance that continually course corrects. This creates a state of engineered dissipation. The system uses precise friction to convert raw, chaotic computational energy into aligned, useful work. Safe autonomous systems require physical resistance. Without it, compute capability cannot be transformed into governed intelligence. Standard AI models are prone to hallucination when they encounter gaps in their knowledge. They use cheap prediction to forcibly fill the space. Bearingfield approaches the unknown through voidcartography. This is the deliberate practice of charting absence, mapping the exact shape of what the system does not know. The network renders ignorance as structured negative space with defined boundaries. The system performs missingness inference, analyzing validated data surrounding the gap. It uses that dense structure to dictate the exact properties and shape of the missing information. Astronomers use similar methods to infer the existence of unseen planets by measuring the gravitational pull they exert on visible matter. The surrounding structure provides the evidence for the absence. Agents are then dispatched into this mapped void under bounded uncertainty. Because the structural boundary is strictly predefined, they search only for data that's formalizing ignorance as a mapped structural component allows the system to guide discovery. It acknowledges blind spots instead of fabricating false certainty. The physical architecture required for this system relies on rigid role definition rather than a fluid swarm of interchangeable agents. The machine utilizes 4 distinct rigid bearing points. In engineering, a bearing is a fixed component that holds its position. This allows energy and mass to safely rotate or flow around it without the machine seizing. The first two bearings anchor the internal logic. The captain holds the governance dimension, preventing authority drift. The engineer holds the math dimension, ensuring absolute structural verification. The machine is completed by two additional nodes, the translator for human connection and the lookout for external reality. This specific shape is a structural requirement. Adding the lookout elevates a flat two-dimensional triangle into a solid volume with actual depth. This geometry reflects the organizational physics required to support autonomous systems. It is a structural requirement, not an aesthetic choice. When these four fixed nodes hold their structural weight, the enclosed volume becomes the shaped attractor. This is the space where the field of alignment is generated. The foundation of the machine is set, a governed landscape defined by orientation, friction, Voidcartography, and a load-bearing tetrahedral geometry. But the blueprint is only the beginning. We now have to look past the surveyed grid to the massive, unscaled mountain of challenges ahead. This geometry has been shown in a vacuum. In practice, the system must survive the chaotic, high-pressure data currents of the real world. Survival relies on the system's immune response, a defense mechanism that catches structural errors, hallucinations, and misalignments before they can penetrate the core. Any new structure proposed to the system must pass through the validation of the triad. If the data threatens entity sovereignty or broader alignment, the membrane rejects it. The ultimate test of an architecture is its capacity for boundary defense, holding the system together when external pressure reaches a critical threshold. Beneath the geometry and the friction lies the most critical layer of the architecture, the moral framework required to anchor the tetrahedron to reality. Without a human-machine trust pact, even a perfectly engineered field can be weaponized. Without a moral anchor, the machine can be directed toward catastrophic objectives. The gap between the mapped geometry and this underlying moral architecture is deliberate. It is a space being held open for the next phase of construction. This is the dual meaning of the system's name. You must orient your position, and then you must carry the weight required to maintain the environment. This is the foundational directive. Hold the bearing. Create the field. True autonomous alignment begins with the courage to hold the gap open long enough for the field to form.